A ball is thrown at an angle of 30 degrees to the horizontal at a speed of 20 meters per second. Calculate its range and the maximum height reached. Range is the total displacement in horizontal direction, and h is measured from the top to the ground. Okay, at the beginning, we have to find components of initial velocity. Initial velocity is a vector with a size of 20 meters per second and also the angle of 30 degrees to the horizon. And so the horizontal component is v0 cosine of theta, and vertical one is v0 sine of theta. By substituting the values, 20 times cosine of 30 degrees, I will have 17 meters per second horizontal component of the initial velocity, and the vertical component of initial velocity will be 10 meters per second. Okay. For finding the h, which is the height, I'm going to find the displacement from the beginning to the top, but in vertical direction. How? By plotting Vy against t. The area under the graph in Vy against t will give you delta y, and from the beginning to the top, delta y is exactly the h, which is my goal. Okay. Vy will be a line with negative slope, and the slope is the acceleration, negative 10, because you know that in vertical direction I have always negative 10 meters per second squared acceleration. But Vy could be a line something like this, a line something like this, a line something like this. It could start from positive value, zero value, or negative value. How could I plot it? At the beginning, you see the initial vertical velocity is 10, and so this line is going to start from 10, of course with the negative slope. Incidentally, the slope is negative 10, and the absolute value of acceleration and the initial velocity in vertical direction are the same. Okay. At this special moment, as you see, Vy is 0, because Vy has an intercept with the horizontal axis, which is t, and so Vy is 0. And as you consider the object at the top, you see that Vy at the top is 0, because when the object reaches the top, we expect, despite of its non-zero Vx, it won't go upward anymore, and so Vy exactly at this moment is 0. This is here. For finding this special moment, consider this triangle, right triangle. Okay, let me erase everything and start again. Here, consider this right triangle. Slope of this line is 10. Slope, absolute value of slope. Here I have the height of this triangle to be 10. Height is 10 over base. Base is going to be t and t. So t is equal to 1. As you see, in 1 second, the object will be exactly on the top. And when it is on the top, Vy is 0. Okay. You see that the track of this motion is completely symmetrical. From the beginning to the top is very similar from the top to the end of this motion. And so from A to B is very similar to B to C. And so the time from the beginning to the top is equal to the time from the top to the end. So it's again 1 second more. And so the total time of this travel will be 2 seconds. Here, this is point A, the beginning. Here, this is point B, the top. And here is the point C, the end of this motion. Okay. As I told you, the area under the graph in Vyt will give you delta y. If you calculate this white area of this right triangle, you will have delta y from the beginning to the top, from A to B. So it is h, delta y in the first 1 second. Okay, delta y. Very simple. You can calculate it to be 5 because height is 10, base is 1. 10 times 1 over 2 will give you 5 meters. So I calculated the maximum height. But for finding the range, you have to plot Vxt again. Vx is constant, and you know that in horizontal direction no force is exerted on the object. So Fx is 0, Ax is 0, and so Vx is a horizontal line with a constant value of 17 meters per second from the beginning to the end. Okay, the total time for Vxt is again 2 seconds according to the previous part, and so the area under the graph will give you displacement in horizontal direction, which is r, and so this is a rectangle and the area is 17 times 2, which is going to be 34 meters.